Okay, everybody, welcome back. So we're going to be teaching about calculating average atomic mass. Okay, now this week we're going to have a test. You're going to get a study guide tomorrow, and you're going to be working on today calculating average atomic mass after the notes. Remember, your test on Thursday, that's when it's going to be. You have to log in sometime between 9 and 3. And once you open it, it's going to be 50 minutes timed. So you can't close out and go do something. It's on Edge Elastic, so you'll need to log in to Edge Elastic. Remember, on your Chromebooks, do not log in first. You'll click on the Apps button, click on Edge Elastic, and then you will log in through Google at that point. Okay, so please don't forget that you do have a test this week. All right, so let's go ahead and start talking about how we calculate average atomic mass. So first of all, I know back in the day they used to tell you guys when you look at the periodic table to round that average atomic mass number. Please, 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 that's not how you should do that, because the mass number is actually in reference to individual isotopes of an element, okay? It's not the average. So when you look at the periodic table, you're looking at an average atomic mass. You're not looking at an individual isotope, so you don't ever round that number, because it's an average of all of the isotopes and their abundance in that sample. So last week you did a lab on pomponium in which you calculated the mass of pom-poms, right? And you had to look at individual isotopes, calculate your percent abundance, and then multiply your average mass for each one by the relative abundance, and then add everything together. And that calculated your atomic mass of pomponium. And so we're going to review that today about how we calculate the average atomic mass of individual elements, okay? So first of all, when we do estimate mass number, when you do that, it's going to be off of an individual isotope. So here, as you can see, all of these numbers right here are going to be rounded based off of the mass of one isotope, not the average and the abundance of all the isotopes, okay? So this number will be rounded to 38, this isotope to 39, this isotope to 40, and this isotope to 41, okay? Now, by just looking at these four isotopes, you can probably assume which of the four isotopes probably occurs more often than the other, based on the percentage, right? So it's out of 100%. So if you look right here at isotope 2, 79% almost of that isotope occurs out of 100 samples. So 39 is going to be the isotope that occurs most often. So when we actually calculate the average atomic mass, it's going to be closer to 39 than it will to any of the other isotopes, due to the fact that it occurs more often out of 100 atoms than any of the others. Okay? So let's just talk about what is average atomic mass. Okay? Oops, sorry, went too far. So average atomic mass is the weighted average mass of the isotopes of the element. So when you're calculating it, you're going to take the atomic mass that's given, you're going to times by the percent abundance given in the problem for each isotope, and then divide by 100. Then you will take the sum of all mass contributions, and that's going to give you the atomic mass of the sample. Okay? So let's look at, just in the mere chance that you have a box of marbles, okay? And the box contains two sizes. If 25% have a mass of 2 grams and 75% have masses of 3 grams, what is the weighted average? So first thing I did there was took both percentages out of percent abundances and divided them by 100. So I said 0.25, and I'm going to multiply that by the mass of my first marble. Then I'm going to take, I had 75% of 3 grams. So I take that, divide it by 100, and I take 0.75 times 3, and then I get 0.5 for the first one, and I get 2.25 for the second one. If you add those two together, you're going to get an average atomic mass of 2.75 grams. So that would be your weighted average atomic mass for the marbles. Okay? Now, what if we took this a little bit further and tried to calculate the average atomic mass for these individual isotopes? Now, whenever it's given, I prefer for you guys to always use the given mass, the decimal number, okay? Because it's more accurate. Now, there are going to be occasions in which you get the isotope symbol. When you have the isotope symbol, remember that's going to have the rounded mass number on there. So in that instance, you can go ahead and use the rounded mass number. But if in the problem I do give you those masses, those average masses, I want you to use the decimal numbers because they are more accurate, okay? So now, for the first problem, we're going to start with isotope 1, okay? Now, isotope 1 has a average mass of 37.765. We're going to take that number, that mass number, and we're going to multiply it by the percent abundance and divide by 100. And that's going to give us a mass of 3.65, okay? Then we're going to look at isotope 2, and we're going to take the mass of isotope 2 times by its abundance, divided by 100, and that's going to give us 30.73. Next, we're going to do isotope 3, and we're going to take 40.003 times by the percent abundance, divided by 100, and that's going to give us 4.54. Last, we're going to take isotope 4, and we're going to say 41.060 times the percent abundance, divided by 100, and that's going to give us 0.13, okay? Now, once you've done that for all your isotopes in the problem, you are then going to add everything together, and you should get an average atomic mass of 39.05, or something close to that, okay? So that becomes your average atomic mass for element X, okay? Now, the isotope which exists in greater abundance has the greater effect in determining the atomic mass of the element. So, like we said earlier, here's my average atomic mass. Because element 2 had a high abundance, the average atomic mass is going to be closer to that isotope, okay? All right. Now, using your periodic table, try to identify element X, okay? So if you were looking at your periodic table, you would see that element X is in fact potassium, okay? Has an atomic mass of 39.04, very, very close. Okay. Now, let's move to the next problem, okay, on your set of notes. Now, what if we were looking for copper? Copper has two naturally occurring isotopes, okay? Copper 63 occurs 69.1% of the time, and copper 65 occurs 30.9%, okay? Now, the next question you're gonna ask is, well, how did you know it was that percentage? Well, remember, everything's out of 100%. So if I know that this is 69.1%, I can say 100 minus 69.1, and that's gonna give me the percentage of the second isotope, okay? So now let's go ahead and start calculating. Remember, even though I have my rounded mass number, if they give me the decimal number in the problem, that's what I want you to use when calculating average atomic mass. So here we have 62.93 times the percent abundance divided by 100, and that's going to give me 43.48. Okay? Now, I've already subtracted, right? I subtracted off my 100 from 69.1, and that gave me 30.9%. So now I'm going to take 64.93 times 30.9% divided by 100, and it's going to give me 20.06. Now remember, once you've done all of your isotopes, the last step is where you're going to add all of your isotopes together to get your average atomic mass, which for copper is 63.54. And remember, you can predict what it's going to be closest to, right? We know that 69% of it, okay, is copper 63. So it's going to be closer to copper 63 than it will be to copper 65. All right, let's try one more, okay? So magnesium has three isotopes. 78.89% is magnesium 24, okay? 10% is magnesium 25. And then what is that left with? That's 11.01%. Once again, how did you figure out that 11.01%? Well, I took 100 and I subtracted 78.89%, and then I also subtracted 10% off. And that left me with 11.01%. That's how I figured out the percentage for the third isotope, okay? So now I'm going to take my atomic masses like I did before, and I'm going to multiply by my percent abundance, divide by 100, okay? So let's just go ahead and try each isotope. So magnesium 24, remember, they gave me the decimal number. So that's what I'm going to use when calculating the percent abundance. So 23.9850 times 78.9% divided by 100 is going to give me 18.92. Next, I'm going to take 24.9858 times by 10% divided by 100, and that's going to give me 2.49. Last, I'm going to take 25.9826 times 11.01 divided by 100, and that's going to give me 2.86. Once you've done all of your isotopes, the last step is going to be adding all three together to get an average atomic mass of 24.27. Okay? And that's my average atomic mass for magnesium. Okay? I hope you guys enjoyed the lesson. Have a great week.